This is a chemical process called electrolysis, used the other way. So, this is my final project for my CAD class. It might look confusing and stupid, but let me explain. Oops. So, this little plastic box I designed and 3D printed in SolidWorks. These wires are connected to these 4 batteries. This provides a DC voltage input, with this one being the positive wire, this one is the negative. And as you can see, there's gas being generated. On this side should be hydrogen, the side that it's pointed at. The other side is producing oxygen. This is my design for this part. You could also, in theory, fill this up 100% of the way, in which case it'll fill to exactly 100 milliliters. And you can put like a plate or something on top of this, and like bags here, and it would collect oxygen on this side and hydrogen on this side, or you know, it depends what battery it's connected to. That would determine the polarity of the electrodes, which one's a cathode and which one's the anode. This one should be the cathode, I believe, because it's negative. So this is a dual output electrolysis chamber. Yeah, you might be doubting right now if this is actually generating hydrogen and oxygen gas, but I can prove to you that it is right now, because if I remove the one of the wires, then the circuit would be incomplete and the chemical reaction stops. But you couldn't see me undo the wire, so I'll try and zoom out so you can. Alright, I hope you can see the gas bubbles. I can't tell. Yes. So, let me just zoom out. Now when I remove this, pardon the wind, doing this outside, as you can see, the gas bubble, crap, it's not letting me zoom in, sorry. The gas bubbles have stopped being generated. I'm just going to hold this here for a minute. Sorry about the shaky hand movements, I'm doing this on my phone. Alright, the electrode is connected again, and it whizzes back to life. Off, and on. It's amazing to think all this chemical reaction can come from 4 AA's.